Hi, and welcome to the videos for section 2.2 for Math 126. This is the first of two videos for this section. So in section 2.1 we learned about functions. What are they? In section 2.2 we're going to graph or graphs of functions. And in this first video specifically, we're going to be looking at our three basic types of graphs. And then we'll learn how to manipulate them in future sections. But for now, we just need to know, what does the basic graph look like? In chapter 1, we are doing some graphs on the coordinate plane. And what do? We just plotted points, right? Pick a value for x. What's the value for y? Plot it. What's the value for x? What's the value for y? Plot it. Get a bunch of points so we can connect the dots. We're going to do the same thing here for each of these examples. So the first one is I want to graph f of x is equal to x squared. Again, we're just going to start with some basics here. So this is really like what? Remember in section 2.1, we can rewrite f of x as basically y. So this is, we want to graph y equals x squared. So if I build a table, my x and my f of x, let's pick a couple negative numbers. We'll pick 0, we'll pick 1 and 2. So if I plug in negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is positive 4. So this gives me 5 values. So I have what? I have negative 2, positive 4. So the x always is left or right first. So 2 to the left, 4 up. 1 to the left, 1 up. 0, 0, that puts me at the origin. 1, 1, so 1 to the right, up 1. 2 to the right, up 4. So what this is, this shape, even though it might look like a V, it's actually like a big cup, and we'd seen this in some of the chapter 1 videos. And this guy here, x squared, is known as a parabola. This cup can be pointing up or pointing down, depending if we have negative signs in here somewhere. And you notice I put the arrows on the end, because it's not just these 5 points. It goes forever to positive infinity on both sides. So when I have a function x squared, that's going to be a parabola, and again it can be manipulated if I add some few things in, and we'll see that in some future sections. The second graph I want to look at, the second basic one, let's call it g of x is equal to x to the third. So remember, the f here is just the function name. So function f is x squared. Function g is x to the third. Again, if I build a table, x, and so g of x, again, let's do negative 2, negative 1, 0, 1, 2. So negative 2 to the third power, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 1 to the third power is negative 1. 0 to the third power is 0. Positive 1 to the third power is positive 1. And positive 2 to the third power is positive 8. So this one here so I have the point negative 2, negative 8. So that means 2 to the left, 8 down. 2 to the left, 8 down. I have a point there. 1 to the left, 1 down. 1 to the left, 1 down. 0, 0. 1 to the right, up 1, 2 to the right, up 8. So this shape, whenever I have an x to the third, this is not an official math term, this is my term. It's basically a snake. Going down here, comes up, it's a little flattened out, and then back up. Whoops, and hitting my point there, if I adjust my point. So it's kind of this curve that goes to the origin, kind of snakes through the origin, thus calling it a snake. So when I have an x to the third, this should be the general shape that you get. And the last basic graph we're going to look at is h of x is equal to the square root of x. So again, h of x just means we're calling this function h. When I do this, I'll graph it the same, I'll build a table, but what am I restricted by now? So we have what? Our domain. My domain, that's all these values I'm picking for x, the independent variable. But when I have square root of x, I'm restricted by what? I can only have 0 and positive numbers. So in this case, I'm going to pick, whoops, not 0 up here. That's my x. So I'm going to pick 0, I'm going to pick 1, and in this case, I'm going to pick 4 as my point to plug in, and you'll see why here. And so my h of x, the value that gets kicked out, well, if I plug in 0, I get what? Square root of 0 is 0. If I plug in 1, square root of 1 is 1. And here's why I picked 4. If I pick 2, which I could have, if I plug in 2, what do I get? Square root of 2, which I don't really know where that falls on the graph. It's not a nice, clean number for me. But if I plug in 4, if x is 4, h of x, or my y value, is what? Square root of 4, which is 2. So now if I plot these points, 0, 0 is the origin, 1, 1, so 1 to the right, 1 up, 4 to the right, 2 up. So this graph gives me the shape essentially starting at the origin and heads up into infinity, kind of like a fireworks or a rocket, I guess. So I don't have a left and a right side here. I just have the graph that starts at the origin, goes off to the right, always getting bigger and bigger as I get closer to infinity. So that's it. That's your basic graphs, the parabola, the snake, the fireworks, or the rocket, depending if it's x squared, x to the third, or square root of x. Come on back in video 2, we'll look at some piecewise functions, and then how to be able to tell if something is really a function or not.